Atomic Theory Timeline 1803 Solid sphere Dalton atoms are dense and solid, with no internal structure or subatomic particles considered 1897 Thomson atoms are described as uniform, positively charged spheres with electrons embedded within them, similar to raisins in a pudding. 1911 Nuclear Rutherford atom consists of a small, dense, positively charged nucleus at the center, with electrons orbiting around it, similar to planets orbiting around the Sun. 1913 Planetary Niels Bohr. Electrons move in quantized, discrete energy levels around the nucleus and emit or absorb energy when transitioning between levels. 1920 Quantum Erwin Schrödinger electrons do not have definite orbits, but are described by wave functions that represent probability distributions of their locations. John Dalton 1766–1844 British chemist and physicist. Proposed the solid sphere model in the early 19th century, shifted from philosophical ideas to scientific theory. First atomic model based on experimental evidence and quantitative observations. Paved the way for the development of motor atomic theories. J. Thomson 1856–1940. English physicist known for his work on the nature of electrons. Proposed the plum pudding model in the late 19th century, discovered electrons as distinct particles. Shifted understanding from indivisible atom to subatomic particles. Paved the way for further exploration of atomic structure. Plum pudding model. According to this theory, atoms are like plum pudding, with tiny positive charges scattered throughout a cloud of negative electrons. This theory helped explain why atoms have a neutral charge overall and why they emit light when they collide with each. Limitations couldn't explain why electrons didn't collapse into the positive sphere. Failed to predict the distribution and arrangement of electrons. Lacked explanation for the nucleus and its positive charge. 1937 New Zealand-born physicist known for his contributions to nuclear physics. Introduced the nuclear model in the early 20th century, first model to propose a central, massive nucleus. Explained the behavior of positively charged alpha particles in the gold foil experiment. Laid the groundwork for understanding atomic structure and radioactivity. Nuclear model 1911. According to this theory, atoms have a nucleus with a positive charge and most of the mass, surrounded by electrons that orbit like planets. It explains why particles can pass through or bounce off atoms, and is the basis of our current understanding of atomic structure. Limitations didn't explain the stability of the nucleus against electrostatic repulsion. Lacked details about electron orbits and energy levels. Didn't incorporate the principles of quantum mechanics. Niels Bohr, Danish physicist known for his pioneering work in atomic structure. Proposed the planetary model in the early 20th century, explained atomic spectra with precision. Introduced the concept of quantized energy levels. Bridged classical physics with emerging quantum mechanics. Niels Bohr, Danish physicist known. Planetary model summary. Theory of electron orbitals. Electrons orbit the nucleus in specific energy levels or shells. Explains atomic light emission and absorption of specific colors. Clarifies atomic stability and why atoms remain intact, limited to explaining the hydrogen atom. Couldn't account for the behavior of multi-electron atoms. Didn't incorporate the wave-like nature of electrons. Erwin Schrödinger. Austrian physicist renowned for his contributions to quantum mechanics. Proposed the quantum model in the 1920s. Quantum mechanics provides a comprehensive understanding of electron behavior. Schrödinger's model successfully explains multi-electron atoms. Quantum mechanics is the foundation of modern atomic theory. Quantum model electron theory. Electrons exist as a probable wave-like pattern around the nucleus. Explains dual nature of electrons, particles and waves. Fundamental to atomic structure and modern physics. Mathematical complexity of the model. Requires advanced mathematics to calculate electron probabilities. Doesn't provide a simple visual representation of atomic structure.
Time to test your knowledge of the atomic theory.
If atoms are solid spheres, what would happen if you tried to cut one in half? Type your response in comment section. How would you describe the distribution of raisins, electrons, in this atomic pudding? Type your response in comment section.